Okay, so last time we were left off with this piecewise function to graph. So let's go ahead and graph this. And what I'm going to do is I'm just going to graph each of these functions separately first, just as a little bit of a different approach, and then combine them to get the final graph. So I'm going to have three graphs. So first we graph x cubed plus 1, and if you do that, here's the point 0, 1. So this is just y equals x cubed plus 1. You'll get something like this. And then there is y equals minus 2x, which is just for a placeholder here. If I plug in 2, I'll get minus 4, which is over here. If I plug in 0, I'll get 0. So we have something like this. So how do we get the piecewise function? Well, we stop. So here, 2 cubed plus 1. So here, if I had 1, 2 somewhere out here, this point would be 2, 9. Here I have the point 2, negative 4. So what I do is I say, okay, up to 2, if I want to finally get the graph of f, so here's now the graph of f of x, our graph, I say, okay, I want exactly this graph, but only up till x equals 2. So I go up to 1, 2, and I say, I go up to here, which is the point 2, 9. Here, this keeps going forever, but this stops on this side. Then I want the rest of the graph beyond 2, negative 4. So 1, 2, 3, 4. But I don't want to include that particular point because I have a strict inequality here. So notice here I want x strictly greater than 2 is what I want there. So I make a little opening here. And then the graph continues from there. Okay. So this line is, this is not part of the graph. I'm just going to, this line right here is the dividing line. Okay. On the left, you have the first graph. On the right, you have the second graph. Okay. Again, this line is not part of the graph. I just drew it there to indicate that that line is where the graph splits into pieces. Hence, it's called a piecewise function. Okay. Let's go to a slightly different but related topic. And this is still part of 2.2. This is how to determine if an equation or a graph defines y as a function of x. So how do you know that you have a function? How do you know that y is a function of x? And so we're going to do two methods here. One is the graphical method. And the graphical method is called the vertical line test. So let's do an example here. Remember, if y is going to be a function of x, then so just before we do this, a reminder. Y is a function of x. Y is a function of x if for each x value there is exactly one y value as the output. So if you have an x value and there's multiple outputs anywhere, then that's not going to be a function. Of course, it's possible for some x values, it's not even in the domain. Here by default, I'm assuming x is going to be something that you can actually plug in. So for each x that you can actually plug in, there should be exactly one y value as the output. And let's do an example of the equation. We're going to graph an equation x equals y squared. Okay. So this is the graphing of an equation. It's not necessarily, and we're going to see that it's not going to be a function, but it's just an equation. It's a set of x and y values. And, well, let me plug in a few values for y and x. So if y is 1, x is 1. If y is negative 1, x is also 1. Well, you can already see here that I have x being 1 and multiple outputs. So already we can see just by these numbers, this is enough to show this is not a function, i.e. y is not a function of x. But just to see it visually, I'm just going to go ahead and graph it. If y is 0, x is 0. And we're going to get this following sideways parabolic shape. Okay, so we have 1, 1, we have 1, negative 1, and we have 0, 0. And just extrapolating, it shouldn't be so sharp here. It should be a bit smoother. Sorry about that. You get the idea, though. So this is the curve. It's a sideways parabola. And you can see here that the fact that there are multiple outputs. So for this single x equals 1, we have y equals plus or minus 1. So we have a single input, multiple outputs. That corresponds to the fact that if we draw a vertical line through this vertical line, or a bunch of these vertical lines, so pass through the graph twice. So note that for a single input, x equals 1, the fact that there are multiple outputs corresponds to the fact that the vertical line crosses the graph multiple times. So it corresponds to the vertical line x equals 1, or any other x value except for x equals 0, crossing the graph twice. Okay. Multiple outputs, I guess exactly, in this case, 2 outputs. So what does the vertical line test say in general? So the vertical line test says the following. If any vertical line crosses a graph more than once, because there are certain lines that may not cross the graph multiple times. So for example, in this case, if I take this line, the y-axis itself, it only crosses the graph once. But there are others that cross multiple times. So if any vertical line crosses a graph more than once, then the graph, or the corresponding equation, is not a function. And when I say not a function, I mean y is not a function of x. So y is not a function of x. Okay, so that's the vertical line test. And let me just draw some random curves, and we can kind of just decide just a couple more here. If I had something like, so this is example 1, example 2, I should say. Okay, let's just do these two. So notice, what do we want to do? We want to check if these curves define a function of x. Are these functions of x? And hopefully you can see here, just staring at these, for this one, if we draw any vertical line, it only crosses the graph once. So for this it's a yes, it is. Whereas here, some vertical lines may not cross the graph more than once, but then, for example, here we do cross the graph multiple times. So here we have no. Okay. So visually, you can kind of just tell from the graph whether something's a function or not. But the second part of this, the second part of the question is, can we check algebraically? Because not all equations are going to be easily graphed. Can we check algebraically whether y is a function of x, whether y is a function of x or not? And the answer is yes. And what we're going to do is we're going to do it kind of by example here. So as an so for first, I'm going to show. So our first example is how to show something is not a function. Because showing something is not a function is actually easier than showing something is a function. And let's go back to x equals y squared here, because we already know that it's not a function. How would we show this algebraically? Well, just plug in, if you can plug in a number of x, so plug in a value of x so that when you solve for y, you get multiple outputs. So for example, I could set x to be, so let x be 9, and you have then y squared is equal to 9. If you solve for y, you get plus or minus 3, right? Which means that there are two solutions to, there are two y values that correspond to this x value. So hence, y is not a function of x. Okay? So, and I'll leave an exercise for you guys to try that's going to be somewhat similar to this. So this is how you would show something is not a function. Plug in a value of x in that equation and solve for y. Try to get multiple values. Okay? All right. Let's do an example of how to show something is a function. Some equation does define a function. And the method is simply, it's now generally solve for y as a function of x. Simply stated, solve for y. So for example, suppose we had the following equation. So x squared plus xy is equal to y plus 1. And you say, okay, does this define y as a function of x? And normally, if all of the y if you have odd powers of y, this is not always true, but if you have only the same odd power of y, notice in the last example we had an even power, right? X, y squared. If you have a same odd power of y, it's usually a function. Usually a function. So for example, in this case, let's solve for y. How do we do that? Well, let's isolate the y's. X, y, let's subtract y here. Bring the x squared onto the other side to get negative x squared plus 1. We're going to factor out the y here to get y times x minus 1 equaling negative x squared plus 1. And finally, we get a y equals, dividing both sides by x minus 1, we get negative x squared plus 1 divided by x minus 1. So notice here, I solved for y and I got y on the one side, and everything else is just a function of x. Okay? So I need to end up with, so now I can write this as y is a function of x, because we have exactly what it is. And if you can do that, then y is a function of x. Okay, so hence y is a function of x. Okay, let me leave you with 2 exercises. So for one here, you're going to check whether these define, algebraically, you're going to check if these define y as a function of x. And here we have 2x to the 4th plus y squared x is equal to x minus 1. So what you want to do is check if these define y as a function of x. And if your intuition says that it is, then try to solve for y. If it's not, plug in a value for x and try to get multiple outputs for y. And we'll start with this example in the next video. This exercise in the next video, and this is but also the end of